Work in design labs like the Wearable Sensors Lab increasingly uses digital manufacturing technologies like 3D printers, laser cutters, and digital embroidery machines. These machines simplify already existing processes and allows for new design possibilities, but they are rarely used together due to the inherent incompatibility of different machines. To facilitate turn-taking between machines, we designed a simple software tool we call MOAS. Through the use of MOAS, we propose Exquisite Fabrication as a game of designally Exquisite Corpse by allowing samples to travel between machines to make, for example, soft inflatables.
Our soft inflatable was made using digital machine embroidery and cast silicon. The base layer was made with digital embroidery and sent through the mail since not all machines were in the same physical location. Step 2 was to print molds on top of the sample that were later used to cast silicon. The sample was attached to the 3D printer and stickers were placed where the molds would be printed. The stickers served as a placeholder for the design and show the outline of the model and markers for alignment. Through the interface of the machine, the coordinates of the markers were recorded and used to position the digital model in the printer's software. The stickers were removed and the printer was started. The next step was to fill the molds with silicon. The silicon printer was aligned to the stickers in the same way as the regular 3D printer. The molds were filled with silicon one by one. The final step needs to be done by the embroidery machine, so the sample was sent back through the mail. The sample and an alignment sticker were attached to the embroidery frame. 2 of the markers are used to align the machine to the sample. Through the interface of the embroidery machine, the digital file can be positioned within the work area. This means we can directly align the machine using the sticker. No extra steps required. In the last step, tubing is attached to be used to control the inflation. The end of the tubing is connected to the silicon inflatable and carefully routed over the sample, while the machine stitches it in place using a couching stitch.
MOAS simplified the process of aligning the sample to the machines. The process builds on the existing capabilities of each machine and appends these where needed to achieve a continuous workflow that is easy to understand and does not require any alterations to the machines themselves. In this way, Exquisite Fabrication allows designers to combine multiple digital manufacturing technologies and to collaborate over large distances while working on the same sample. In conclusion, we took 4 steps of fabrication by turn-taking between 3 machines and 2 designers. Through this process, 3 concerns emerged: turn-taking, improvising and understanding machines, and trade-offs. In this paper, we propose a set of guidelines that suggest ways to allow different digital fabrication machines to be used in sequence as a way to add complexity to the things we make and the ways our machines may talk to one another, allowing us to ask the question: if we can play Exquisite Corpse with these 3 machines, what else can we do?